Hello friends and my dear students, I welcome you all to my channel. I hope you are all well and your studies are also going on well. This is part 5 video on the from the chapter of Physical Quantities and Measurements, where I will solve 10 MCQ problems on the topic of relative density. In the previous part 4 I discussed about the key concepts and formula of relative density of a substance. If you need to have the concepts, if you need to know the concepts, then please do watch the part 4 video. And if you like this video, if you find this video beneficial, then please like it, share it with your friends. And if you want to further support me, then please subscribe to my channel and also do not forget to press the bell icon so that you will be notified by my future videos. So let's get started with part 5 video, where I will solve 10 multiple choice questions on the topic of relative density. Okay. Uh, so the first question says that, so this is set 1. There will be set 2 of similar multiple choice questions. I don't know whether I will be able to frame 10 questions or not, but I have already framed 5 questions for set 2. So let's see. Okay, so question number 1 says the relative density of a substance is X. A block of the substance weighing Y kgf has a volume of. Okay, so the relative density is given. Now, when a relative density of a substance is given, we immediately know its density either in gram per centimeter cube or kilogram per meter cube. Now, it is also given that the block of the substance the weight of the block of that substance is Y kgf. So, Y kgf implies the mass of the block is Y kilogram. So, this is the definition of kgf. Kgf is a gravitational unit of force, and weight of a substance is nothing but the gravitational force that is acting on the on that body. So, a body having a mass of Y kilogram, on that body, the gravitational force will be in the gravitational unit Y kgf. Okay, so we know the mass of the block is Y kilogram. So we have to find the volume of the block. Now we know the mass, we know the volume. What do we need? We know the mass. So let's say, so mass we know is Y kilogram. We have to find the volume of the block. What do we need? We need the density. If we somehow know the density of the substance, basically the density of the block means the density of the substance, then we can easily find the volume. How do we know the density of the substance? We can easily know the density of the substance from the relative density. The relative density of the substance is given as X. So I can say we know the formula that density of a substance is equal to RD, that is the relative density of the substance, this much gram per centimeter cube, and also the density will be 1000 or 10 to the power 3 multiplied by RD. This will be in kilogram per meter cube. We know this formula. We studied this formula in the previous part 4 video. Okay, so the density of the substance will be X gram per centimeter cube, since the relative density is given to be X. Now the mass of the block we know is kilogram. So we have to either we convert the mass in gram and then find the volume in centimeter cube, or we can convert the density in kilogram per meter cube and then find the volume in meter cube. Either way you can proceed, but since in the options you can see the volume is given both in centimeter cube and meter cube. So let's find Let's work with the CGS system. So mass is y kilogram. This is y multiplied by 10 to the power 3 gram. Okay, and we have already density is x gram per centimeter cube. So volume will be mass divided by density. So this is y multiplied by 10 to the power 3 gram divided by x gram per centimeter cube. This is nothing but gram cancels out, and we have from the denominator we have centimeter to the power minus 3. It will go up as centimeter cube. So this is we have y by x multiplied by 10 to the power 3 this much centimeter cube. Now let's see if our result matches with any of the choices which are given in centimeter cube. Choice A is y multiplied by 10 to the power minus 3 by x. No, choice A is incorrect. This is wrong. Let's see choice B. It says y into 10 to the power 3 divided by x. So this is correct, since this will be the volume of the block of the substance in centimeter cube, that is y by x multiplied by 10 to the power 3. So immediately we can say choice B is the correct. Now since these are all single correct multiple choice questions, that is only one choice will be correct, we can immediately we need not see the choices C and D. If you verify, you will see. Okay, let's see what will be the volume. What will be the volume in meter cube? We know that how do we convert centimeter cube into meter cube? We know 1 centimeter cube is equal to 10 to the power minus 6 meter cube. So the volume will be y by x. We have 10 to the power 3, and then we have to multiply with 10 to the power minus 6. This will be in meter cube. This becomes y multiplied by 10 to the power minus 3 divided by x. 1 meter cube. Okay, so I can also see that choice D is given as y into 10 to the power minus 3 by x. So choice D is also correct in meter cube. Let me quickly verify. 1 centimeter cube is 10 to the power minus 6 meter cube. I hope this is correct, because 1 centimeter is 1 by 100 meter, which is 10 to the power minus 2 meter. So centimeter cube will be 10 to the power minus 2 whole to the power cube. That's that much meter cube. Yes, it is 10 to the power minus 6 meter cube. So the volume is also will be y into 10 to the power minus 3 divided by x meter cube. So choice D is also correct. Okay, so I'm really sorry. I can see that two choices are coming out to be correct, but my original intention was to make all these questions single correct choice multiple question. That is, only one choice will be correct. Anyway, I'm sorry for that. So choice B and D are correct. Will be the volume of the block of substance. Okay, let's see the next problem. Now, if I am doing any kind of mistake in the calculation regarding volume, conversion of unit, or applying any wrong concept, I will highly appreciate if you let me know in the comment section. Question number 2 says the relative density of a solid sphere is P. If the mass of the sphere is in kilogram, then the radius in meter of the sphere is. We have to find the radius of the sphere. So to find the radius of the sphere, definitely we have to find the volume of the sphere. Now the relative density, it is given the relative density of the solid sphere is given to be P. Okay. So since the mass of the sphere is given in kilogram and the radius of the sphere is also asked in meter, let's solve the problem using SI unit. So this implies I can say that the density of the solid sphere, will be equal to, remember, in kilogram per meter cube, it will be 1000 or 10 to the power 3 multiplied by RT, this much kilogram per meter cube. This is in general formula of the density, the relation between density and the relative density of a substance. So rho, which is the density, is equal to 10 to the power 3 multiplied by RT, which is the relative density of the substance, this much kilogram per meter cube. Since the relative density is given to be P, this becomes 10 to the power 3 multiplied by P, this much kilogram per meter cube. Okay. So we know also the mass of the solid sphere is given to be m kilogram. Okay. So from here we can clearly find the volume from the formula that density is mass by volume. We can say that the volume will be equal to mass by density. Now the mass, please do not get confused with this capital M on the left hand side. By that I mean the mass, and the actual value of the mass is also capital M, kilogram. Let's say, okay, I hope you will understand. So this is equal to M by what is rho? Rho is P 10 to the power 3. This much it will be meter cube. So this is the volume of the solid sphere. Now we are asked to find the radius. So also we can say, if we consider the radius to be r meter, we can say the radius, the volume of a solid sphere of radius r is 4 by 3 pi r cube, this much meter cube. So we can equate the both, we can equate both the value of the volume, that is using the formula 4 by 3 pi r cube, and also we know using the m by p, we get m divided by p multiplied by 3 is equal to 4 by 3 pi r cube. From here we can easily find, we have to find r. Okay, so what will be r? R cube. R cube will be 3 by 4 pi multiplied by m divided by p multiplied by 10 to the power 3. So this is equal to thrice m divided by 4 pi p and multiplied by 10 to the power cube. Okay. So what will be r? So r will be definitely the cube root of the right hand side. That is, r will be I can say cube root of 3m divided by 4 pi p multiplied by 10 to the power 3. So this is in the radical form, this cube root. If I want to express the radical form in the exponential form, this will be 3m. Cube root means a power of 1 by 3. So 4 pi p multiplied by 10 to the power 3, this whole raised to the power 1 by 3. Okay. Now in the denominator we have 10 to the power 3. So I can, so this will be, if I hope you will, I hope you're familiar with the chapter of the mathematics, exponents and powers and the laws of exponents. I hope you will understand if I simplify this as 1 by 10. In the denominator we have 10 to the power 3 and the whole expression has power of 1 by 3. So in the denominator the power of the 10 to the power 3 and that whole raised to the power 1 by 3 will become 10. So we have 1 by 10 multiplied by 3m divided by 4 pi p, and this whole raised to the power 1 by 3. So R is 1 by 10 uh, multiplied by an exponential term, and the exponential term, the base is 3m by 4 pi p, and the power is, or the exponent is 1 by 3. This should be the answer. Let's see the choices. So the correct choice is choice B. Is the correct choice. Okay, let's see the next problem. Question number 3 says the relative density of mercury is 13.6. Find the ratio of the mass of mercury of a certain volume to that of water at 4 degrees centigrade having 10 times the volume of mercury. So we are given the relative density of mercury as 13.6. So immediately we will know it's the density of the mercury either in gram per centimeter cube or in kilogram per meter cube. Always remember that from the relative density you can always know the density of the substance. Now then the question is asking find the ratio of the mass of mercury of a certain volume to that of the mass of the water at 4 degrees centigrade having 10 times the volume of mercury. Okay, first of all, so relative density of the mercury is given as 13.6. So this implies density rho of mercury. Now the symbol in chemistry, I hope I am not wrong, in chemistry the symbol used to denote mercury is Mg. So this means I am trying to say the density of mercury will be equal to now since in this problem no unit is mentioned, you can consider the density to be in CGS or in SI unit. It will not make any difference, but please be consistent. So let's say the density of the mercury will be 13.6 gram per centimeter cube. Okay. Now it is asking find the ratio of the mass of mercury of a certain volume. Nothing is mentioned what that volume is. So let's consider. Let the volume be. Let the volume of mercury. Mg means mercury. Be V centimeter cube. Okay. So this implies mass of V centimeter cube of mercury will be equal to its density multiplied by the volume, that is V. This much it will be gram. Now the density of the mercury is 13.6 gram per centimeter cube, and so this will be basically if I put the values of the density, which is 13.6, and so this will be 13.6 multiplied by V, this much gram. Okay. Now the question is asked to find the ratio of the mass of a mercury of a certain volume to the mass of water having a volume 10 times that of mercury. So mass of 10V, 10 times the volume of mercury. We have assumed the volume of mercury to be V centimeter cube. So 10 times volume is 10V. 10V mass of 10V centimeter cube of water at 4 degrees centigrade. What will be the mass? It will be the density of the water, which I am denoting with rho W, multiplied by its volume, that is 10V. This much gram. So remember that we have to consider the density of the water in gram per centimeter cube, and we know the density of water at 4 degrees centigrade is 1 gram per centimeter cube. So this will be 1 multiplied by 10V, which is equal to 10V gram. Okay. So the ratio will be ratio of masses. We have to find the ratio of the V centimeter cube of mercury to that 10V centimeter cube of water. So mass of V centimeter cube of mercury was 13.6 multiplied by V, and this much gram, and the mass of 10V centimeter cube of water is found to be 10V, this much gram. So gram will cancel out, VV will cancel out. So this is 13.6 divided by 10, which is 1.36. So the ratio will be 1. So the ratio is 1.36 is to 1. So the correct choice is C. C is the correct choice. Okay, let's see the next problem. Question number 4. An irregular shaped crystal was fully dropped into a liquid of density x kilogram per meter cube, and the weight of the overflowing liquid is found to be m1 GMF. Weight of m1 GMF means the mass of the overflowing liquid is m1 gram. Okay. If the weight of the crystal is m2 GMF, which means that if the mass of the crystal is m2 gram, then the relative density of the crystal is. Okay. So we are asked to find the relative density of the crystal. Okay. To find the relative density of the crystal, we need to find the density of the crystal. Then only we can find its relative density. How do we find the density of the crystal? Okay. So an irregular, so let's say consider. So what is happening is that, so an irregular shaped crystal was dropped into a liquid of density x kilogram per meter cube, and the weight of the overflowing liquid is found to be m1 GMF. Now, the volume of the overflowing liquid will be equal to the volume of the crystal, because the crystal is it is said that an irregular shaped crystal was fully dropped, means the crystal is fully immersing, is being fully immersed into the liquid. So in that case, the volume of the liquid that will be displaced or that will overflow will be equal to the volume of the crystal. Okay. Now, so we need to find the mass of the crystal is given, which is m2 gram. If we know the volume of the crystal, then we can find its density. We can find the density of the crystal, and from there we can find the relative density. So let's see. So the mass of the crystal is given to be, we know it is m2 gram. From the fact that the weight of the crystal is m2 GMF, which means that the weight is a force and it is given in gravitational unit, that is GMF. So which means that m2 GMF means a gravitational force which is acting on a body of mass m2 gram. So the mass of the crystal will be m2 gram. Okay. Now, what will be the volume of the crystal? If I consider it to be V, it will be equal to volume of liquid uh, displaced or overflowing. Overflowing. Okay. Now, how do we know the volume of the liquid that has overflown? To know the volume of the liquid that has overflowed, we need to know its mass and its density. In the problem, the density of the liquid is given as x kilogram per meter cube. Okay, so so the volume of the liquid displaced will be its mass, which is m1 gram. Since it is given the weight of the overflowing liquid is m1 gmf, which means the mass of the overflowing liquid is m1 gram. So the volume of liquid displaced will be its mass, which is m1 gram, divided by the density of the liquid, which is given in kilogram per meter cube. Let's convert the density of x kilogram per meter cube in centimeter in gram per centimeter cube, and it will be x multiplied by 10 to the power minus 3 gram per centimeter cube. So this becomes, we can see that the volume V, the volume of the crystal, which is equal to the volume of the liquid overflown or displaced, is coming out to be m1. M1 in the denominator we have 10 to the power minus 3. We can simplify it as m1 multiplied by 10 to the power 3 divided by x. This much centimeter cube is the volume of the crystal. Okay, so we know the volume of the crystal, we know the mass. So what will be the density of the crystal? The density of the crystal is mass divided by volume, which is equal to m2 gram divided by V is m1 multiplied by 10 to the power 3 divided by x, this much centimeter cube. So this becomes, after simplification, x m2 divided by m1 multiplied by 10 to the power 3, this much gram per centimeter cube. So we have found the density of the crystal in gram per centimeter cube, and we know that from the relation between density and relative density, we know that in gram per centimeter cube, the density of a substance is equal to the relative density. So we can right away say that the relative density of the substance will be equal to x, x m2 divided by m1 multiplied by 10 to the power 3. This should be the relative density of the crystal. Now let's see. The correct choice is choice D. D is the correct choice. Okay, let's see the next problem. Question number 5. Relative density. Now, wherever you will see RD in the problem, it means relative density. So, relative density of two substances X and Y are P and Q, okay, respectively. What is the density of X relative to Y? What is the density of X relative to Y? Okay. Now, let's say I'm using some terms. Let's say I'm using some notation. Let's say this be the density of the substance X, and let's say rho Y be the density of the substance Y. Okay. Now, the question has asked the density of X relative to Y, which means density of X relative to y means this is equal to the ratio of the density of x and the density of y, that is rho x and rho y. This is what we have to find. We have to find the ratio of density of x and the density of y, but we do not know the density of x or the density of y. We only know their relative densities. Now, what will be rho x? Rho x. Now, if I consider, since no unit is given, I can always consider the density of x using the relation between density and the relative density. I can always say that density is equal to the density of a substance. If I denote it with rho, it will be equal to its relative density, this much gram per centimeter cube. So I can say that the density of substance X will be equal to P gram per centimeter cube. Since the relative density of substance X is given to be P, so I can say the density of X is P gram per centimeter cube. Similarly, I can say the density of Y will be equal to Q gram per centimeter cube. So now I can find rho x by rho y. This will be equal to P gram per centimeter cube divided by Q gram per centimeter cube, and after simplification this is nothing but P by Q. So the correct choice is C. Okay, let's see the next problem. Question number 6. If the ratio of the density of ice to that of wood is 9 by 8, okay, and the relative density of ice is 0.9, then the density of wood in kilogram per meter cube is, okay. So we are asked to find the density of wood. Now, whether it is asking in SI or CGS, that is not important. We can always convert the value of density from CGS to SI and vice versa. So basically, we have to find the density of wood. Now, how do we find the density of wood? There is no concept of mass or volume. So we have to definitely find the density of the wood from its relative density. So how do we find? Also, how do we know the relative density of wood? It is only given that the ratio of the density of ice to that of wood is 9 by 8. And the relative density of ice is 0.9. Okay. And the relative density of ice is 0.9. Okay. Okay, so let's say since the ratio of the density of ice and wood is given, let's say I'm using some concept of ratio and proportion from mathematics. So I'm denoting the density of ice to be rho I. Let rho I is equal to 9x, and I am denoting rho W to be wood. In general, W is used for rho W is used for the density of water, but please in this problem, since okay, let's use W small d, which means wood. So the density of wood to be 8x. Since the ratio of the density of ice and the density of wood is given as 9:8, I am assuming that let the density of ice be 9x. Oh, sorry, I have to use the unit. I have to use the unit. Okay. Since the density of the wood is asked in kilogram per meter cube, let's say the density the density of ice be 9x kilogram per meter cube, and the density of wood be 8x kilogram per meter cube. Okay. Now, uh, mm, the relative density of ice is given to be 0.9. Oh, I think it's quite simple. I'm unnecessarily complicating the solution. Okay. So the relative density of ice is 0.9. RD ice is given to be 0.9. So I can clearly know its density of ice. So density of ice, which I am denoting with rho I, will be equal to, let's find the density of ice in kilogram per meter cube. So this will be 0.9 multiplied by 10 to the power cube, this much kilogram per meter cube. Applying the concept that the density is equal to RD multiplied by 10 to the power 3 in kilogram per meter cube, or the density is also equal to RD this much in gram per centimeter cube. Okay. So we know the density of ice is 0.9 into 10 to the power 3 kilogram per meter cube. Okay, so how do we find the density of wood? It is given that the density of ice is to the density of wood. The ratio of the density of ice to that of wood is given as 9:8. So this implies rho I divided by rho WD is equal to 9/8. So this implies rho WD, that is the density of wood, will be equal to 8/9 multiplied by rho I. This is equal to 8/9, and the density of ice we have found to be 0.9 multiplied by 10 to the power 3, this much kilogram per meter cube. If I simplify this, this will be 9 will cancel 0.9 with 0.1. So this will be 0.1 multiplied by 8 is 0.8. This much 0.8 multiplied by 10 to the power 3, this much kilogram per meter cube. If I further simplify this, this will be 800 kilogram per meter cube. So the question has asked that then the density of wood in kilogram per meter cube is, definitely it will be choice B, 800 kilogram per meter cube. Okay, let's see the next problem. On dropping 10 identical lead shots into a measuring cylinder containing a liquid, the level of the liquid in the cylinder increases from V1 centimeter cube to V2 centimeter cube. Okay, so some lead shots, 10 identical lead shots means the volume of the volume and the mass of each individual shots will be equal, and the shots are made of the substance lead. Okay, so when 10 identical lead shots are dropped in a measuring cylinder, definitely the volume will the volume in the reading in the measuring cylinder will increase by a volume which will be equal to the volume of the 10 shots, 10 lead shots. This is the concept. Okay, so it is given that the level of the liquid in the cylinder increases from V1 centimeter cube to V2 centimeter cube. Find the mass of each lead. Find the mass of each lead shot if relative density of lead is X. Okay. So So it is the problem is asking to find the mass of each lead shot. Now to know the mass of each lead shot, what do we need? We need its density, that is the density of lead, and the volume of each shot. So first of all, we need to know the density. Now the problem is asking, the problem has given that the relative density of lead is relative density of lead. I think that the symbol for the chemical symbol in chemistry, LD is the symbol for lead. Anyway, if I am wrong, it's fine. Let's suppose LD stands for lead. So the relative density of lead is given to be X. So I can clearly say that the density of lead will be equal to X gram per centimeter cube. But since the volume is given in centimeter cube, so let's use CGS system, CGS unit system. Okay, so the density of the lead will be equal to X gram per centimeter cube. Okay, so we know the density of lead. Now to find the mass of each shot, we need to know the volume of each shot. Then, since we know the density of lead, then we can easily find the mass of each lead shot if we can find the volume of each lead shot. So we have to find the volume of each lead shot. Okay. Now, as already discussed, definitely the volume of 10 lead shots will be equal to the rise in measurement of volume in the measuring cylinder, which will be equal to V2 minus V1 centimeter cube. Before it is given that when the 10 identical shots were dropped into the measuring cylinder, the level of the liquid, that is the measurement, rises from V1 to V2, which means that what is the change in volume? The change in volume is V2 minus V1. So this change in volume is nothing but the volume of all the 10 identical shots. Okay. So this, since all the shots are identical, that is all the shots, individual shots are having same volume or equal volume, I can say that volume of a single shot, volume of a shot is equal to V2 minus V1 divided by 10. This much centimeter cube. Okay. So I know the volume of each shot. I also know the density of lead. Since all the shots are made up of lead, I can clearly find the mass of each lead shot. Mass of each lead shot will be equal to its volume, which is V2 minus V1 divided by 10. This multiplied by the density of lead, which is X. So this much whole gram will be the mass of each lead shot. So this is X multiplied by V2 minus V1 whole divided by 10. This much gram is the mass of each lead shot. Now let's see the choices. So clearly, okay. Now if we consider gram, the choices A and B are only in gram. Definitely choice A is incorrect because we do not see the factor of 10. So in the choice B, it is quite similar, but it is given as V1 minus V2, but it should be V2 minus V1. So choice A and B are incorrect. So definitely we have to see what will be the mass in kilogram. So this will be X. How do we convert gram to kilogram? Definitely we multiply with 10 to the power minus 3, this much kilogram. If I simplify this further, this will be to the power minus 3 10 square 100x. Uh, Let me check once again if I correctly used the units. So volume of 10 lead shots will be definitely V2 minus V1 centimeter cube. So volume of each a single shot will be V2 minus V1 divided by 10 centimeter cube. Okay. So also the density of, we have considered the density in gram per centimeter cube. So since the relative density of lead is x, so density of lead will be x gram per centimeter cube. Okay. So the mass of each lead shot should be its volume, that is V2 minus V1 by 10 multiplied by the density of lead, which is x, this much gram, which becomes x into V2 minus V1 divided by 10 gram. If we convert this to kilogram, we have to multiply with 10 to the power minus 3, and this is coming out to be x multiplied by V2 minus V1 divided by 10 to the power of 4, this much kilogram is coming out to be the answer in kilogram, and none of the choices C and D are matching. I think I gave the choices C and D I gave incorrectly. One of the choices should match with the correct answer that I am getting, which is x multiplied by V2 minus V1 whole divided by 10 to the power 4, this much kilogram. So this should be the answer, and none of the choices is matching. So it's my mistake that I could not provide the correct answer in one of the choice. I'm sorry for that. So the volume of mass of each lead shot will be x into V2 minus V1 divided by 10 to the power 4 kilogram, or it should be x multiplied by V2 minus V1 divided by 10 gram. So these two are the correct mass of each lead shot. Okay, let's see the next problem. X ml of a liquid weighs W kgf. Okay, so x ml. Okay. Then the relative density of the liquid is, okay. Now, whenever we are asked to find the relative density of the liquid, we have to know its density, either in any system, in SI or CGS. So from the fact that XML of a liquid weighs W kgf, we have to find the density of the liquid. Okay, so weight, as already explained in the previous problems, weight of a W kgf implies the mass of liquid, that is the weight of liquid is given to be W kgf. This implies the mass of the liquid is W kilogram. kgf is, as already explained earlier, kgf stands for kgf is the gravitational unit of the weight, and weight is nothing but a force. So what exactly is W kgf? It is the gravitational force that is acting on a body of mass W kilogram, as simple as that. If it was W gf, then it would mean the gravitational force which is acting on a body of mass W gram. Okay, so the mass of the liquid is W gram. Also the volume, let's say the mass be denoted with M. Volume of the liquid is given to be x ml. Now, we need to, since we know the mass of the liquid in kilogram, let's find the volume in meter cube. Now it is the volume of the liquid is given in milliliter. Now you must know that 1 milliliter is equal to 1 centimeter cube. Also, you must know that 1 liter will be obviously 10 to the power 3 centimeter cube. So 1 milliliter means 1 centimeter cube. So this is equal to x centimeter cube. The volume of the liquid is x centimeter cube. Now we need to know the volume in meter cube. Since we have the mass in kilogram, we need to know the volume in the meter cube so that we can find the density in SI unit, that is in kilogram per meter cube. From there we will find the relative density. Okay, so this will be equal to or it's better since we know the volume is already given in we know the volume is x centimeter cube, let's convert the mass into gram. So the mass m will be definitely W multiplied by 10 to the power 3 this much gram. So the volume is x centimeter cube and the mass is W into 10 to the power 3 gram. So the density of the density of the liquid will be mass by volume, which is equal to W multiplied by 10 to the power 3 divided by x, this much gram per centimeter cube. So if we know the density of a substance in gram per centimeter cube, whatever that value will be, so this is the value of the density, and the unit we know is in gram per centimeter cube. So we can right away say that the relative density of the liquid will be equal to W into 10 to the power 3 divided by x. So this is the relative density. So the correct choice is D. D is the correct choice. Let's see the next problem. Question number 9. A bottle when half filled with water at 4 degrees centigrade weighs x gmf. Okay, so this means that the mass of the bottle plus water plus the water whose volume is the capacity of the bottle or the volume of the bottle at 4 degrees centigrade is x gram. So the mass of a bottle when half filled with water, the bottle when half filled with water weighs x gmf. So okay, that is the volume of water, the mass of water whose volume is half the volume of bottle plus the mass of empty bottle is x gram. Okay, so let's try to visualize. So we are having a bottle. Let's say this is the bottle, and when it is half filled with water, let's say this is water. The total mass is given to be x gram, and the volume of the water is half the volume of the bottle. So if the total volume is V, if the total volume if it is V centimeter cube total volume, so the volume of this water is V by 2 centimeter cube. Okay. Now it is saying that after the remaining half of the bottle was filled with the liquid X, the weight of the bottle is Y gmf. So now the remaining half of the bottle, so initially the half of the bottle was filled with water. Now let's say this is the liquid, the remaining half is filled with a liquid. Now the total mass, that is the mass of the water, the liquid and the bottle, is given to be Y gram. Okay, if the empty bottle weighs 3 gmf, so definitely the empty bottle has some mass, so it will have some weight. So let's say it is given that the empty bottle, the weight of empty bottle is z gmf. So if I consider small m to be the mass of empty bottle, it is given to be z gram. It is given that the weight of the empty bottle is z gmf. So it means that the mass of the empty bottle is z gram. Okay, and I am denoting the mass of the empty bottle to be small m. Okay. Now, if the then the relative density of the liquid X6, we have to find the relative density of liquid X. Now, how do we know the relative density of liquid X? In this problem, the alternative formula of relative density will be used. That is, we know that the relative density is also of a substance is also equal to mass of, let's say, some volume of that substance, let's say V centimeter cube, divided by the mass of same volume, that is V centimeter cube of water at 4 degree centigrade. We know this as the alternative formula of the relative density of a substance, which is equal to the mass of V centimeter cube of that substance divided by the mass of V centimeter cube of water at 4 degree centigrade. Now, we can clearly see that the volume of the water and the volume of the liquid are same, and they are both equal to half the volume of the bottle. So we can clearly, if we can somehow find the mass of the water and the mass of the liquid, then we can clearly find the relative density of the liquid. So how do we find the mass of the water and the mass of the liquid? Okay, so if we consider small m to be the so the mass of the empty bottle is z gram, and it is given that when the bottle was only half filled with water, the total weight was x gmf. Okay, so it was given as x gmf. From this information, can I find the mass of the water which is half filling the bottle? Let's say m1 be mass of water, that is mass of water having the volume of half the volume of the bottle, and let's say m2 be mass of liquid. Also, the volume of the liquid is half the volume of the bottle. Now, from this, we can say that, so initially, what will be the mass of the empty bottle and the mass of the water? It will be small m, that is the small m we are denoting for the mass of the empty bottle plus the mass of the water, m1. So this should be equal to x, because initially it is saying that a bottle when half filled with water weighs x gmf, which means that the mass of the empty bottle and the water is x gram. So I can say m plus m1 is x. So from here clearly we see that that m1, that is the mass of the water, is x minus m. Now what is small m? Small m is nothing but the mass of the empty bottle, which is given to be, we have found to be z gram, from the fact that the empty bottle weighs z gmf, which means that the mass of empty bottle is z gram. So this is x. So this is x minus z. X minus z is the mass of the water. Similarly, when the remaining half of the bottle was filled with the liquid, the total weight of the empty bottle plus water plus liquid is given to be YGMF, which means the mass of the empty bottle plus water plus liquid is Y gram. So I can say that m, small m, the mass of the empty bottle plus m1, that is the mass of the water, and let's say the mass of the liquid be m2. This is given as y. You can say this is y. Okay. Now, m small m is the mass of the bottle, which we know is z. So we have z plus m1 plus m2 is equal to y. We need to find m1 and m2. We have already found m1, which is x minus z. Now we are finding m2. So from here we will get m2 is equal to y minus m1 minus z. This is y. What is m1? M1 is x minus z. We have minus z. So this is y minus x plus z minus z. This is equal to y minus x. So M2 is that is the liquid mass of the liquid is y minus x, and the mass of the water is x minus z. So definitely from these two facts, and also knowing that the volume of the liquid and the water is same, we can say the relative density of the liquid will be equal to the mass of the liquid, which is y minus x, divided by the mass of the water of the same volume, which is m1, which is x minus z. So y minus x divided by x minus z should be the relative density of the liquid. So the answer is choice D. Okay, let's see the last problem, question number 10. A wooden block is tied to a metallic rod of mass m, capital M gram, and immersed completely in water. Okay. So a wooden block is tied to a metallic rod of mass. So the mass of the metallic rod is capital M gram, and they are both of them are completely immersed in water. The volume of the displaced water is found to be xml, which means that the volume of the total volume of the wooden block and the metallic rod is xml, because when a body is completely immersed in water, the amount of water displaced is equal to the volume of the substance. Okay. If the density of rod is rho gram per centimeter cube and the relative density of wood is y, then the mass of the wooden block is okay. So we have a wooden block tied to a metallic rod. Okay. Now to find the mass of the wooden block, what we need to know? We need to know the volume of the wooden block and the density of wood. Okay. The relative density of wood is given, which is y. So from there we can clearly find the density of wood. So we know the density of wood. If we can find the volume of the wooden block, then we can easily find the mass. So how do we find the volume of the wooden block? Okay, let's say V WD is volume of wooden block. And similarly, let's say B, a metallic rod, let's say R, B, volume of metallic rod. Okay. So we can say the volume of the wooden block and plus the total volume of the wooden block and the metallic rod should be equal to the volume of the displaced water. So we have VWD plus VR, that is the sum of the volume of the wooden block and the metallic rod is equal to the volume of the displaced water, that which is x ml, which is equal to x centimeter cube. Okay. Somehow we have to find the volume of the wooden block. Now from here we can find the volume of the wooden block. If we can find the volume of the rod, can we find the volume of the rod? The density of rod is given to be the density. Okay, so the mass of the rod is given. The mass of the rod is given to be m gram. Also, the density of the rod is given. So we can clearly know the volume of the metallic rod. So VR, what is VR? The volume of the metallic rod will be its mass divided by its density. The mass of the metallic rod is given to be m gram. M gram divided by the density of the metallic rod, which is also given to be rho gram per meter cube. Rho gram per meter cube. So we can see, we can easily know the volume of the metallic rod to be m, capital M by rho, this much centimeter cube. Okay, this is the volume of the metallic rod. So now we can see, using this equation that we got earlier, we can say that volume of rod, volume of the metallic of the wooden block will be equal to x minus VR, this much centimeter cube. This is equal to x minus VR. VR is the volume of the rod, which we have found to be m by rho, this much centimeter cube. This is equal to, if we simplify, x minus m by p, it will be rho x minus capital M divided by rho. This much centimeter cube is the volume of the wooden block. So we know the volume of the wooden block, but we know the relative density of the wood is Y. So we can say, if the relative density of wood is Y, we can say the density of wood is equal to Y gram per centimeter cube. If the relative density of the wood is Y, then clearly we can say that the density of the wood is Y gram per centimeter cube. Okay. So now we can easily find, we know the volume of the wooden block, we know the density of the wooden block, we can clearly find the mass of the wooden block. So, and the question is asked, then the mass of the wooden block is, okay, so mass of wooden block will be equal to definitely density of wood multiplied by the volume of the wooden block. The density is Y, and the volume we have found to be rho x minus m divided by rho. This much gram should be the mass of the wooden block. Okay, what are the choices? Okay, if I simplify this, if I write it neatly, this will be Y multiplied by rho into x minus capital M whole divided by rho, this much gram. Let's see what are the choices given. In the choice A is given to be Y into rho minus mx. No, the answer is rho x minus m. So clearly A is incorrect. B is given as Y into rho x minus m divided by rho gram. Okay, so clearly B is the correct choice. B is the correct choice. I'm not even verifying whether the choice C and D are correct or not, but since it is a single correct choice, choice B is the right choice. So with this, it comes to an end in solving 10 numerical problems based on the relative density of a substance. I hope this video will be beneficial. If so, then please once again, please like it and share it with your friends. And if you want to further support me, then subscribe to my channel, and also do not forget to press the bell icon so that you will be notified by my future videos. I will try to solve another 5. I have already prepared another set 2 of 5 problems. I will solve that and prepare a video tomorrow. And after that is done, I will move on to the next topic, which I think should be how do we measure the density of liquids and irregular solids using some standard devices like measuring cylinder or density bottle, all this stuff. So I will. So thanks for watching. I will end the video here, and until the next video, take care and bye.